Are you ready? That was me diving into homework help. Ha! Okay. So, the second part of 3.9. So you start at number 22 and you go through 38. So the first four, it says solve each quadratic equation over the set of complex numbers. That means you're going to be dealing with I. So I decided to do number 23. T squared plus 24 equals 0. Okay, so we're going to use the quadratic equation. So I'm going to identify A, B, and C. T squared plus 24 equals 0. So A goes with the highest power, with the squared, so A is 1. B is, where we're looking for AX squared plus BX plus C equals 0. Okay, so we're looking for A is 1. B, there's no term with just an X. We talked about this yesterday, I think. There's no term with just an X. So B is 0. And then C is 24. Okay? All right. Then let me write down the quadratic equation. Negative B plus or minus B squared minus 4AC all over 2A. All right, there it is. So then we're just going to substitute in. So we're going to use a different color. There it is. So negative B. So B is 0. Oh, well, okay. So B is 0 plus or minus. All right, now we're going to do our discriminant. B squared, which is just still 0, minus 4 times A, which is 1, times C, which is 24. All over 2A. 2 times 1 is 2. Okay? If you don't want to show this part of your work where you substitute in 0, you don't have to. Okay, because now I'm going to start writing it. So now we just have plus or minus. 0 doesn't do anything. So I have negative 4 times 1, which is negative 4. And then negative 4 times 24. Oh, geez. Okay. 24 plus 24 is 48. 48 times 2 is 96. Negative 96. I'm pretty sure that's right. Let me check my math real quick. Oh. Hold on one second. I have a missed phone call. It might be importante. It wasn't really that important. I bought a new pair of shoes over the holidays, but they were sold out of the color I wanted. So they special ordered them for me, and it's just been kind of a mess. But it's okay. Anyways, so negative 4 times 24 is in fact negative 96, and that is all over 2. So let's move this way. So this is where your I is going to come in. Well, not yet. We're going to break down 96. Okay, we're going to factor 96. So it's 24 and 4. Oops. Factor the 4, 2, 2, prime, prime. 6 and 4, 8 and 3, 2 and 12, 2, 8 and 3. 8 and 3, 3 is prime. Factoring, factoring, goodness gracious. Okay, so then the square root of 96, can we see this? Yes, is 1, 2, 3, 4, 5. 5 twos. 1, 2, 3, 4, 5, and a 3 times. So let's keep simplifying. 96, group of 2, pull out a 2, group of 2, pull out another 2, and then these have to stay underneath the radical. So then you have 2 times 2, and then inside the radical, you have 2 times 3, which is 6. And then multiply these together, so you get 4 square root of 6. Goodness. Okay, so I'm going to erase all this work because it's taking up a lot of room. Really, I guess what we should have done before, sorry, I'm going to backtrack just a little bit, is we should have done this. So this is going to be equal to plus or minus, I'm going to break it apart, the square root of 96, the square root of negative 1. And this is what's going to turn into our I. Remember, I is equal to the square root of negative 1. So I separated it, and this is still all over 2. Okay, I think maybe that's easier if we do that step first. So then we factored 96, and so we got the square root of 96 is equal to 4 times the square root of 6. Did I lose anyone there? Okay, so we got here, and then really, I would go ahead and break this apart. If you know that it's just going to be the square, whatever the square root of 96 is, and then times I, then that's fine. But I'm going to break it apart. So I just broke it apart into the square root of 96 times the square root of negative 1. I can do that. If I multiply these together, I just get the negative square root of 96. Sorry, the square root of negative 96. Okay, so these are the same thing. These are equal to each other. All right. Now, we figured out that the square root of 96, I'm going to go up here, is 4 square root 6, and then that's times I. I wonder how they want you to write it, on the inside or on the outside. Okay. So it's right on the outside. So 4 square root of 6 times I all over 2. All right, so I substituted this in for the square root of 96 because we factored this and got the prime factors, and that's how we got 4 square root of 6. So I'm substituting that in for the square root of 96. And then I is equal to the square root of negative 1. I should write that somewhere. I is equal to the square root of negative 1. So I substituted in I for the square root of negative 1. So that's where I got my I. And then it's still all over 2. All right. Here we go. Almost done. Oh, there's still a plus or minus. Plus or minus. Okay. Last step is to divide by 2. So just 4 divided by 2 is 2. So you get plus or minus 2 square root 6 I. And that's your answer. Woo! Let me make sure that's right in the book. Oh, you didn't see it. Yes. So that's number 23. Okay, I'm also going to do number 25 from that same section. So we're going to solve it over the set of complex numbers. That means we're going to be dealing with I. Okay. So here's our equation. In your standard form, so you can compare it if you need to figure out what A, B, and C are. A, B, C. A is whatever's in front of the r squared. So there's nothing there, which means there's a 1. A is 1. B is -2. And C is 5. Okay. So this time we have all of our values. So you're going to substitute them into the quadratic equation. So negative b, so that means this is going to become +2 plus or minus b. Now you do the discriminant, b squared. So -2 squared. What's -2 squared? It's 4. 4 minus 4 times a, which is 1, times c, which is 5. All over 2 times a, which is 2 times 1, so 2. Okay? That's everything substituted in. You should be trying these, you should be trying these by yourself, right? And then coming to me if you get stuck. Or if you're just like, Miss Bailey, I have no idea, then okay. Do this one with me, but then try the other ones on your own. All right? Two plus or minus. All right, we have 4. -4 times 1 is -4. -4 times 5 is -20. 20 all over 2. Keep on keeping on. 2 plus or minus. What is 4 minus 20? -16. All over 2. We'll go up here. So let's reduce our radical. 16 is a perfect square. So remember, you can rewrite the square root of -16 like the square root of 16 times the square root of -1. You can rewrite it like that if you want to pull it apart. Right? So then the square root of 16, so we're going to have 2 plus or minus the square root of 16, 4, and then the square root of -1, which is equal to, oh, I erased it, which is equal to I. Why did I erase it? I'll put it over here. I equals square root of -1. Okay. So remember, this is all over 2. So the square root of -16 became 4i. All right. Last step is just to divide. Whenever I pause, it means I'm making you try and think about it before I say it. Okay. 2 divided by 2, 1 plus or minus 4i divided by 2. Is 2i. So that would be your answer. Or your answers. There are 2 of them. All right. 1 plus or minus 2i. Okie dokie. Moving on. Okay, the next part, 26 through 34. This is where you're using the discriminant. So the discriminant is what is underneath the radical. So it's b squared minus 4ac. There. So this is your discriminant. B squared minus 4AC. Okay. So they give you equations. Yes, and you have to use the discriminant to determine the nature of the roots. So are they complex or are they real? If they are real, are they rational or irrational? Let's do 2x squared plus 7x plus 7. That is number 31. 2x squared plus 7x plus 7. Okay. Let me make sure. Yes. This is number 31. So there's your equation, and you're going to use the discriminant to figure out if the roots are imaginary or real. If they are real, are they rational or irrational? Okay. Let's identify A, B, and C. A, B, C, 1, 2, 3. A is 2, B is 7, and C is also 7. All right. So now you have the values. Substitute them into your discriminant and see what you get. If you get a negative number, it's imaginary. If you get a real number that's a perfect square, then it's rational. If you get a real number that's not a perfect square, it'll be irrational. So pause me or something and try it by yourself real quick or real slow. Take all the time you need. Take all the time you need. I will wait. Okay, hopefully you paused me and tried it. So let's substitute in. I know A, B, and C, so we're going to substitute them into here. So B squared. B is 7. 7 squared is 49. Minus 4 times A, which is 2, and C, which is 7. 2, 7. 4, 9. Then you would multiply these guys together. So negative 4 times 2 is negative 8. And then negative 8 times 7 is negative 56. So technically already you could stop because you know it's going to be a negative number, but we'll finish just because it's one more step. So 49 minus 56. Negative, oh my gosh, I can't think, 17. Jeez. But you don't have to write the answer, you just have to write whether it's imaginary or real. Oh, see, I knew I was going to do it wrong. 49 minus 56 is only 7, not 17. This is what happens when you get old. Your brain just lets you down sometimes. Anyways, it's negative. So if your discriminant is negative, then it is imaginary. So B squared minus 4AC, that's your discriminant. If it is negative, then, then it's imaginary. Okay, if it is B squared minus 4AC is positive or 0, positive, then it is real. If it's a perfect square, I should write it further this way. So it's positive, so it's real. If it's a perfect square, I'll move in a second. Hold on. Then it is rational, which they've been using with a Q, whatever. So it's rational, and then if it's not a perfect square, it's irrational. Okay. So, number 31, the discriminant is negative, therefore it is imaginary. Your roots are imaginary. Or complex. You could use either one. You could write imaginary or complex. Alrighty, let's do another one. Woo! Did 31. Let's do 33. 2x squared plus 7x? Yes, plus 7x minus 6. Plus 7x minus 6 equals 0. So identify A, B, and C, and then substitute them into your discriminant and solve. And then say if they are imaginary or real, and if they're real, are they rational or irrational? Pause me and do that, please. Try it by yourself. Okay, hopefully you paused me and tried it by yourself. So let's identify A, B, and C. A is 2, B is 7, and C is negative 6. All right, and then we're going to substitute into our discriminant. So B squared. B is 7. B squared is then 49. Minus 4 times A, which is 2, and C, which is negative 6. All right, negative 4 times 2 is negative 8 times negative 6. What's negative 8 times negative 6? Okay, well, the negatives are going to cancel each other out. So 8, hold on, 2x squared plus 7x minus 6. B squared is 49. Times 2. Okay, I'm not sure if I'm going to agree with the book on this one. So maybe it's a good thing we're doing it. All right, 49, and then negative 8 times negative 6 is 6 times 8 is 48. Oh, I will. Okay. 49 plus 48. So, you know it's going to be a positive number, right? 49 plus 48. Oh my goodness. Okay. Construction. 49 plus 48 is going to be a positive number, so you already know that you're going to have real roots. Your roots are going to be real because positive. Your discriminant is positive. But now you have to figure out if they're going to be irrational or rational. So 49 plus 48 97. 49 plus 48 equals 97. Okay. To tell if it's rational or irrational. If it's rational, this is a perfect square. If it's not a perfect square, then your roots are irrational. So is 97 a perfect square? That means, can you multiply an integer by itself to get 97? You can't. It's irrational. If you weren't sure, I'm trying to think, what is 97? 9 plus 7 is... 97 might actually be prime. 1 second. It's going to be irrational, but... Okay, well, there you go. 97 is actually a prime number. So it's going to be an irrational, because then you would be taking the square root of 97, and it's not a perfect square, it's some decimal. I don't know what it is, but it's some decimal. 9 point something, 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 something. So then your answer here would be real, and irrational. Okay. If you had gotten, so let's say you got 100. You solved it and you got 100 as your answer. Well, then it's still going to be real because it's positive. And 100 is a perfect square. 10 times 10 is 100. So then in this case, it would be real and rational. Okay, so that's the difference. Is that perfect square? Is it a perfect square or not? That determines real or irrational. All right. I actually think that's all I'm going to do today. The last ones, it says solve the quadratic below using an appropriate method. So that doesn't, so you do not necessarily have to use the quadratic equation. So I would check for 35 through 38, I would check and see, can I factor? If you like completing the square, well, you can pretty much always complete the square. It's just not always nice. So anyway, check and see if you can factor. And if you can't factor, then go ahead and use the quadratic equation, is what I would recommend. Yeah, that's definitely what I recommend. But there are a couple of them that you can factor, so you might just want to do it that way because that's easier generally. Okay, that's it. Bye.